Hello there guys, welcome back to another epic and execrable maths video. We've got an integral right here to entertain us since they have shut down the Jeremy Renner app, which is really terrible because I loved going on the Jeremy Renner app and commenting all about Jeremy Renner. I actually don't know how long ago they shut down the Jeremy Renner app. I really have no idea, but I found out the other day, so I'm very sad about that. Anyway, more importantly, we have got an integral to do, okay, and we need to get our hands on it. One thing that we need to remember is this thing here, okay, so the integral of 1 over x squared plus a squared with respect to x is 1 over a times arctan of x over a plus c. If you don't know that, if you're like, what on earth, arctan? I'll leave a link in the description to deriving basically this formula, okay, and we're going to use it. So what are we going to do? Well, it looks a bit crazy. Your first instinct might be, why don't we factorize it and then we can do partial fractions? That's a good idea, but what you'll quickly find is you cannot factorize this because it has no real roots. The discriminant is a negative number, so we're not very happy about that. What we can do though is we can complete the square, and that's the trick here. So x squared minus 8x plus 20 is the same thing as x minus 4 squared, like this, and then if you expanded this out, you'd get x squared minus 8x plus 16, not quite 20, so we need to add our 4 on the end like that. There we go, we've completed the square, dx, okay? Now, this kind of resembles this. Kind of, not exactly. First of all, we need to do a substitution. So we should let maybe u be x minus 4, because that's going to get us to the correct form that we want, and then we can just plug and play. So we can see that du dx is just the number 1, so that's kind of nice and easy. And then so we can rewrite our integral as the integral of 1 over u squared plus 4, and instead of dx, it's just going to be a du, just like that. Kind of nice and simple, right? Because of course du equals dx by that. Then we can realize that 4 is 2 squared, just so that we can more clearly see what our a is. And then we can, again, as I say, we can just plug and play. So this integral, according to that formula there that is derived in another video of mine, this is equal to 1 over 2, because a is the number 2 here, 2 squared. And then we've got arctan, inverse tan of x, or technically u over 2, plus c. The final step, of course, is to replace u with what it is in terms of x. It's x minus 4. So our final answer is 1/2 arctan x minus 4, all divided by 2, plus c. There we go. Nice and easy. I mean, really, only a few steps. Okay, did this do a lot of the heavy lifting? Yes. Is this a difficult formula to derive? If you know substitution, not really. So this is super useful. If you ever see an integral like this in this form where it cannot be factorized, this is what you do. Okay, complete the square like how I've done. Maybe do a substitution if you need to, and then Bob's your uncle, that's the answer. Anyways, guys, thank you so much for watching. I highly appreciate it. As always, please do leave a cheeky little comment. Just say anything. Just say anything you want. Call me names. I don't care. Just boost that algorithm, guys. If you appreciate these videos, just say anything. One word. Just say the word hat. 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 Everyone say hat, please. It will help me out so much, and I will tip mine to you. Thank you so much for watching, and I'll see you in the next one. Cheers.